Now this example is quite cool. We're talking about Morse code, and that is the dots and dashes. That could be sent either as a tone or in light with a torch or something. So you may recognize the tone for SOS, which is did 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 did. But you may also remember that to be did 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 did, which actually means SMS, which is for text messaging. It's short messaging service, I think. So um, these dots and dashes are used quite a lot for sending information quickly down a line when you're trying to just talk about words or letters. Originally, they were used with a small sort of pen tool, and you press down the pen to make a contact, and when the contact is made, you get that tone. So that was all in the I think it was the Second World War, may have been in the First World War. Um, but what about the sending time? So we don't want to spend ages sending these messages. We want to make sure that our message is sent very quickly, as quickly as possible. So that's why when we look at our table down here, the most common letters in the different languages. So in English, the most common letter in every word is E, and the second most common letter is T, A, O, N, and then I. And in French and Italian and Spanish, T doesn't feature at all. So T is not a very common letter in those other languages, but T is very common in English. So if we wanted to send a message quickly, we need to make sure that E, T, A, O, N, and I are going to be very short. And that's why up here that it seems a bit random why all the different um, uh, dots and dashes are not in any sort of meaningful sequence in alphabetical order. So the sending time represents how long it would take to send. So to do the letter A would be one dot, a break, and then a line. The line is 3 sending time units. The dot is 1 sending time unit, and the cut is another 1. So then by looking at I, the reason that's 3 is because it's 1 dot, 1 break, 1 dot. So let's try to write down each one of these letters as time taken to send. So E is going to be just a one unit. The E, it should be a very short. The T should be very short. That's why the T is just a single dash. So the T is a 3. The A was 5. The O is 11. That seems a little higher than it should be. The N is 5. And finally the I, just off the screen here, the I is 3. Now that's odd. You would have expected that O should have been a very short sending time, but it was actually 11. And that is quite strange because here also O features quite high up in Italian and Spanish. I'm not sure what the reason for that is. It's an investigation for another day. So the question here is then asking us to copy and complete the table to find the mean, the median, and the modal sending times for the 6 most frequent letters in each language. So for English, what is the mean sending time for the 6 most frequent? What we'd have to do is add together all of these numbers and then divide it then by 6 because there are 6 terms. So we do 1 plus 3 plus 5 plus 11 plus 5 plus 3, which is 28, and then divide that by 6 to give us 4.7 to 1 decimal place units of sending time. In French, if we did the same thing, we wrote each one of these down as units of time, and then added them together and divided it by 6, we should find that it's 4.3 units. So which is the best language to be sending Morse code in? If you're trying to be quick, it's going to be French because the 6 most popular letters overall have a very low mean time. But then we should look into the median as well. What is the median sending time for English? Well, we'd have to write all of this down in order. So that would be 1, 3, 3, 5, 5, and 11, and then choose the middle one from this. So we've got the first one, the second one, and then the third one. We'd have to add them up and then divided it by 2, which is 4. If we did the same with French, we'd find that the median was 5. So here, the median, it seems favourable to be in English. And what about the mode, the most common letter? So in English, we've got 2 3s and 2 5s, so it's bimodal, you've got a 3 and a 5. The French, it turned out to be 5. The Italian, we would have to decode each one of these into a number and then find the most common number which appears. And if we did that, we'd find it's 5 for both of these. So here again, it's favourable to be English. The most common letter has a 3. So it seems from these 3 averages that English is better. So let's have a look at part B. Use your table in part A to decide which 2 languages are likely to send the quickest message in Morse. So English seems to be good for the median and the mode. The French seems to be best for the mean. What about for part B? So C. Samuel Morse invented the code. Messages in his own language are quick to send. Look at the table of the 6 most frequent letters in each language. Which one of these letters has a code which suggests that Samuel Morse's own language was English? Well, it's because it's better for these 2. It had the lowest median and the lowest mode, and that's why it's more favourable to be English, and so that's why we would suggest from this table at least that Samuel Morse was English. And also T has a very low score on the time, and that's why there's another reason why he could have been English, because if he was French, then he wouldn't have decided that T would have been a particularly low number to send in time. Quite interesting, I think.